Next bit. With nothing connected to the terminals, how much power is delivered by each of the three sources? This was done really not very well in the exam, and I'm not entirely sure why. It's not really a Thevenin question anymore, but you can use the results that you've just worked out. We know from what we've just determined that the open circuit voltage, i.e. the voltage between B and A, when there's nothing connected to the terminals except for these components here, the voltage between there and there is 750 millivolts. I'm free to define the voltage anywhere I want to be ground. Let's just define this point here, the voltage at B, to be 0. That would mean the voltage here would be 750 millivolts or 0.75 volts. Right, this is a 6 volt source, this is a 3 volt source, this is a 4 milliamp current source. The power delivered by a source is related to, at DC anyway, the voltage across that source and the current flowing through it. And if the current is flowing from the higher voltage to the lower voltage, that means that energy is coming out of the circuit. The source is actually removing energy from the circuit. If the current is going from a lower voltage to a higher voltage, that means that the source is having to put energy into the circuit. So, what's happening in this case? Well, we know that the voltage here is 0.75 volts. This is a 6 volt source between 0 and this point here. So this point here in the circuit must be at 6 volts. Similarly, the 3 volt source here, this point here in the circuit must be at 3 volts. We now know the voltages everywhere in the circuit. What about the currents? Well, this is a 3K resistor. The voltage across this 3K resistor is 6 minus 0.75, because we have 6 volts on this side and 0.75 volts on this side. So I know the voltage across this resistor. I know the value of this resistor, so I can work out the current flowing through this resistor. Ohm's law. But the current flowing through this resistor must be the same as the current flowing through this voltage source. It's got nowhere else to go. So I now know the current flowing through this voltage source and the voltage across this voltage source, so I can work out the power being introduced in this case by this voltage source. I'll call that P 6 volts. The voltage across the source is 6. The current flowing through the source is the current flowing through this resistor, which is the voltage across this resistor, divided by the value of the resistor. And that is 6 times 6 minus 0.75 divided by 3K. That'll be about 10.5 milliwatts. And that's power being introduced into the circuit because the current flowing through this component is going from a lower voltage to a higher voltage. It takes energy to get charge from a lower voltage up to a higher voltage. So you have to input power in this voltage source there. Exactly the same technique can be used to work out the power of this 3 volt component. The voltage across the 3 volt component is 3 volts. The current through the 3 volt component is the same as the current through this 1K resistor. The current through this 1K resistor is the voltage across this 1K resistor, which is 3 minus 0.75 divided by 1K. So, the power due to the 3 volt resistor is 3 times 3 minus 0.75 divided by 1K, or about 6.75 milliwatts. Finally, what about that current source? Well, the current source is even easier. I know the voltage across the current source. The voltage across the current source is just 750 millivolts, 0.75 volts. The current through the current source, well, it's a current source. It's a 4 milliamp current source, so the current through the current source will be 4 milliamps. It's that easy. 0.75 times 4, don't even need the calculator, that's just 3 milliwatts. But bear in mind that here the current through the current source is going from a higher voltage to a lower voltage. That's easy. That's falling off the cliff. You've actually got to dissipate energy if you're taking charge from a higher voltage to a lower voltage. So this power, the power in this 4 milliamp current source, is being dissipated, being extracted from the circuit. The two voltage sources, in this case, are putting power into the circuit. May not always be true, depends entirely on the circuit. The way to check: if the current through the component is going from a higher voltage to a lower voltage, then the source is dissipating power. It's removing power. If the current through the source is going from a lower voltage to a higher voltage, then the source is introducing energy. It's doing work. It's increasing the energy in the circuit. Right. I think that'll do for this one.